In the previous class, we have discussed about reason for upthrust and factors affecting the upthrust. In today's class, we will be discussing about a new topic and a very important topic, that is Archimedes' principle. Now, till now what we have discussed is, we have discussed about if a body, if any particle, any object is immersed in water, then what happens? The liquid or whatever liquid we are putting the object inside will give an upward force, which is known as upthrust. Okay? So, with related to that, this Archimedes principle is based. So now I'll just read out the statement and I'll explain it to you. Archimedes principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by it. Now, what it says is, for example, take some amount of water in a bucket, in a bowl, and put some objects in that water. What you can see is, if you have a measuring bowl, then if you have a measuring bucket, then it is very much easy to see the level of the water. So initially, if the level of the water is low, as soon as you put the object, the level of the water will rise. So that level of the water which has increased from initial stage, that is the amount of weight of the liquid which is being displaced from its initial position. It is being displaced because of the object. Like in case if you immerse your body inside a tub of water, then the water level will rise because of your weight of the body. So if you put an object inside any liquid, the water will get displaced. And what this principle says is, the amount of the liquid, the weight of the liquid which is being displaced is actually equal to the upward force. Okay? It's actually equal to the upward force which is being applied by the liquid. So, this is just a statement. There is experimental verification of the same. Okay? There are two experimental verification of Archimedes' principle. Experiment number 1, there is no measuring can, and so we will directly look for experiment number 2. This is verification of Archimedes' principle. Whatever Archimedes was a scientist, whatever he said is actually true or not. Just to verify that, this experiment is done, and even we can do the experiment. Okay? Now, I'll just read it out. Take a solid, suspend by a thin thread from the hook of a spring balance, note its weight. So, initially, what they have taken is, they have taken a solid body and they have hanged the solid body with a spring balance. Now, what a spring balance does? We can see the change in the mark. So, what that shows? It shows the weight of that object. Okay, it shows the weight of an object. So, so initially, okay, I'll just draw the spring balance. Whenever we have an object in the spring balance, there is a place over here, this goes up and down depending upon the weight of the object. So if you now get it a solid, when we hang the spring balance, the weight reads 300. Okay, it reads 300. Now, in the next stage, what they have done is, in this liquid over here, okay, now take a Eureka can and fill it with the water up to its spout. Now, Eureka can is actually a cylinder in which we can measure the amount of water. Okay? It's used in this experiment. Now, in the same place, in the same thing, what we do is, we take a Eureka can, fill it with water, and we put this solid inside the Eureka can. We just take it and put it inside the Eureka can. So what we do is, next stage, we take a Eureka can and we put this inside. Initially, the level of the water in the Eureka can is just near the spout. Spout means a place from where the water actually comes out. A small hole from where the water actually comes out. Initially the level of the water is here. Okay? Before putting this object, the level of the water is at this point. Now, when we put the object, what happens? The level of the water will rise. And what we can see is, whatever amount of water the level will rise, that amount of liquid will flow from this eureka spout. Okay, it will flow from the eureka spout. Now we take another measuring cylinder and we measure the amount of water. So that is there, and whenever we put this solid inside the eureka can, what happens? This spring balance shows a different reading. Because whenever we immerse any object in liquid, the weight of the body decreases. That thing we can even feel in swimming pools. Whenever we float in swimming pool, we feel, whenever we go inside water, we feel that the weight of our body slightly less than the actual weight because of the upthrust. Okay? So whenever we immerse this in liquid, what happens? The spring balance shows a different reading. Now initially it was 300. Now it shows 200. Okay, it shows 200. So the difference in the weight of this object is 100 gram force. Okay, it is the unit of weight, 100 gram force. This is the difference of the weight initially and after putting inside the eureka can. Now, amount of volume over here which is coming out after immersing this in water is 100 gram. Okay, sorry, 100 centimeter. Weight is 100 gram force. So the water which is being displaced is also 100 gram force. Okay, so the weight or the upward force and the weight of the water both is 100 gram force. Therefore, water weight of water displaced is equal to the amount of water which is being displaced coming out of this eureka spout is equals to loss in weight of solid. So whatever is the loss in weight, whatever is the difference in weight in the solid, it is equal to that. This loss in weight of the solid is actually the upthrust. So from this experiment, what is proved is, if you immerse a solid in a liquid, an object in a liquid, then the water is displaced. So the amount of water which is being displaced is actually equal to the force applied by the liquid. So if the weight is more, the force will also be more. This is how we prove Archimedes' principle. For you all, just understand the concept of Archimedes' principle and note down this statement. Okay, that is enough. Note down the statement of Archimedes' principle. Now, the last topic from this part of the chapter is solid bodies with density rho greater than density of liquid sink while the density less than density of liquid floats. Now, previously what we have talked about is force. If the upward force, let's just rub it out. In the previous topic, what we have studied is, there are two forces. If you immerse an object in a liquid, there are two forces. One acting upward, which is the upthrust. Okay. Another one acting downward, which is the gravitational force W. Now, if upthrust is more or equal to the weight, object will float. If downward force is more, object will sink. Now, similarly, we will also discuss the same process in terms of density. Density is denoted by rho. Now we know that different objects have got different density. Solid is denser than liquid, liquid is denser than gas. So in that order, we will just try to understand this concept. So there are three things over here. There are 3 points over here, which is quite similar to the previous point. I'll just read it out. First one is if, okay, this is about the force, okay. First one is if density of the solid, okay, if density of the solid is greater than the density of the liquid, okay, density of the object, if it is greater than the density of the liquid which we are putting on it, then the object will sink. If the object we are putting inside the liquid is heavily dense, then it will sink. Second one is if the density of the object is equal to density of the liquid, again in this situation the object will float. If the density of the object which we are putting inside the liquid is equal to the density of the liquid, the object will float. The third one, that is if density of the liquid is less than the density of the object. Okay, if density of the liquid, the density of the object is less than the density of the liquid. If liquid is more dense than the object, in this case also the object will float. Okay, the object will float. So thus, what we can conclude from here is a body of density rho sinks in a liquid if the density of the liquid is less than the density of the object. Second one, if density of the object is equal or less than the density of the liquid, then it will float. This you can just note it down. Now I'll give you one example. Or there is an experiment done, which is an example. I'll just read it out. Take an iron nail and a piece of cork, both of same mass. We take iron nail. Iron nail is more denser than the cork. Cork is just a combination of some wooden left out things, so it is light. It's less denser than the liquid. So now they have got the same mass. Now when we put that in water, what happens? Iron nail will automatically sink. Okay, it will go inside because the density of the iron nail is more than the density of the liquid. But in the situation of a cork is very light. The density of the cork is less than the density of water. So when the density of the cork is less than the density of water, then what happens? The cork will float. It will not sink. This is what this tree situation means. There can be different situations also, but cork and nail is an appropriate example. Okay. So at last, there is a conclusion. Page number 103. The bodies of density greater than that of the liquid sink in it, while the bodies of average density equal to or smaller than that of the liquid float on it. Okay, this is what you can just note it down, write it in a notebook. What happens when the density is more or less? That will be asked in the question also. Okay, so this part of the chapter is over. Exercise 5A. Okay, there are a few questions. Answer is already given. For those questions whose answer is given, please do not write in your notebook. Only for those questions whose answer is not mentioned, do write in your notebook. Then the numericals part, the numerical portion, that I will solve in the next class. Okay, so this much for today. Thank you, and we'll continue in the next class.